button right now. Next slide, Nick. So we'll be covering a little bit about Climate Smart San Jose today, our adopted REACH code that's currently in place, the proposed expansion that we're here to discuss, benefits of all electric construction, technical assistance, key design considerations, and then question and discussion. So Climate Smart San Jose is the city's climate action plan, and you can see some of our goals listed there on the slide. Specifically regarding all electric construction, we'll be talking today about some of the benefits that you see here, including safer, healthier, more resilient buildings, a pathway for significant emissions reductions, and that the pathway has been supported by the California Energy Codes and Standards as being cost effective. Next slide. So just backtracking a bit, we're actually about a little over a year now out from when we first started down this path. We went to council in September of 2019, adopted a REACH code that covered all new residential and commercial buildings, except for industrial and manufacturing facilities. The requirements of that code right now, if it's all electric, is to meet Title 24. Or if there's going to be natural gas to meet an increased energy efficiency above the base code, and install electric readiness for any mixed fuel uses. It also included electric vehicle charging infrastructure, solar readiness, and electric readiness, again for mixed fuel, and a few variations in requirements depending on the building type. Next. At that council session, council directed us to come back with a natural gas infrastructure prohibition. That also became effective in January 1st of this year. And that prohibited natural gas infrastructure, also known as a gas ban, in new residential buildings that were 3 stories and less, specifically single-family homes, detached accessory dwelling units, and multifamily residential buildings 3 stories and less. So we completed some additional research over the ensuing first half of the year, returned to council in June 9th, on June 9th of this year, with some proposed structure around an expanded natural gas prohibition. I had some analysis that we brought from an experts roundtable we held close to the effective date of our REACH code last year. Technical report performed by our consultants, and then the cost effectiveness studies. Now we have mid-rise and high-rise in hand from the state. At that point, they directed us to return back to council. We had originally tried to do that in September, but had a couple delays, and so we'll be back there on November 17th of next month. So the proposed expansion would cover all new residential, commercial, and multifamily buildings. Exceptions would be hospitals, and then we would allow some specific end use exemptions where that must be applied for cooking equipment and food service establishments or commercial kitchens. So the equipment that would be used to prepare the food could have gas if that was applied for. The rest of the building in that setting would be all electric. Likewise, in industrial and manufacturing settings, if a widget factory came along and they really needed gas to produce those widgets, they could apply for an exemption there. But any office space in that building, for example, would also be all electric. We're trying to provide some lead time there in terms of the effective date. So if we get through and adopt next month, the effective date would be August 1st of next year. Next. Once again, just a little more definition around the allowable exemptions. The exemption for the food service establishments would be available for commercial cooking appliances only. process loads in industrial and manufacturing would be defined as they are in the California Building Code section that's listed there. Hospitals defined under California Building Code Chapter 2. And some of you will recall that we declared a climate emergency declaration last year when we brought our REACH code forward. That provided kind of an outer sunset date for all gas and new construction of effectively the next code cycle. So January 1st, 2023. Right now, that would be the sort of the outer bounds. We're taking a phased approach here. Started off with a smaller subset of building types, expanding and taking probably the biggest step here with this action, and then we would sort of close the door on natural gas and new construction by the end of 2022. Next. So in terms of the process, qualifying building types and occupancies could apply for those specific gas end uses that we mentioned. They would apply for that, and it would be reviewed by the city's planning, building, and code enforcement department. And if it was approved, we would still require electric ready components that are within the REACH code to the exempted gas end uses. So an example of that would be food service equipment that had been exempted through application for use of gas would need to have electric readiness installed under new construction. Anything that's all electric, as it is now, would just meet Title 24. Next. We are seeing a wave of new electric or all electric construction in the Bay Area. The list is growing and growing. We have the third Adobe Tower coming out of the ground here locally in San Jose. City View, which is quite a massive commercial space that's being developed, all electric, and then 200 Park as well, both J-PAL projects planned to be all electric, and then some others you see around the Bay Area there. Next. Health, safety, equity. We know from various studies that burning natural gas indoors can have some harmful indoor air pollution effects. Also transportation of the gas itself, most of which comes from the Midwest, results in fugitive emissions at the site of extraction and through the pipeline process there. You know, obviously gas goes boom, so reducing risk there associated with fire and explosion. And then I just covered the health effects. There's plenty of info out there about respiratory issues, asthma, things like that, especially among vulnerable populations. So a good reason to make our buildings safer and more climate friendly. And then regarding resilience, power for electricity is typically restored faster than for natural gas after larger kind of natural disasters. Next. Just a illumination or illustration of the GHG reducing effect of the proposed code. 2021 is what we look at typically because that's when we expect San Jose's clean energies energy blend to be close to, if not at 100% carbon neutral. And if you focus on the columns on the far right, we anticipate, based on our projected build out here in San Jose, that we could get the equivalent of many thousands of vehicles off the road in terms of the carbon offset from this policy. Next. We do have technical assistance available. San Jose is one of 25 cities in the country to be part of the American Cities Climate Challenge. And through the generosity of our partners, we are able to offer no-cost technical consultation with the Association for Energy Affordability. That is with an asterisk of while supplies last, so get your projects going now. Consultation with city staff is available too. There's an interdepartmental team that brought this REACH code forward. We're always available to talk with projects. Some of the issues that we've been able to help with to date, initially some Title 24 compliance software challenges that I understand are getting much better. Heat pump water heater design and optimization, and then some things kind of embedded, I think, in the compliance approach regarding solar thermal versus solar photovoltaic is how we've helped. With that, I'm going to turn it over to Mr. Nick Young with AEA to talk about all electric construction.
Great. Whoops. Great. Thanks, Ken. Hi, everybody. My name is Nick Young. I'm a senior project manager with the Association for Energy Affordability. We're a nonprofit based in Emeryville, and our work focuses on energy and green building services, primarily for multifamily, but also mixed-use buildings sort of across the state. So yeah, I just want to take some time to talk through some of the basics of all electric new construction and some of the key design considerations for projects as we sort of embark on building without gas, or we sort of continue building on the growing wave of projects that are building all electric. And so often when this topic first comes up, people ask, can you really do it all with electricity? And the answer is absolutely yes, you can. All of the things that we're used to doing with gas, like space heating, water heating, cooking, laundry, pool heating, even fireplaces. You can do all of these things with electricity. And first, I'm going to focus on water heating, but we're also going to talk a little bit about space heating after that. But we'll start with water heating. And when we're talking about water heating, and then also when we talk about space heating in a little bit, we're going to be talking about heat pumps a lot. So I want to start with some basics of heat pumps. This is something that if you're not already familiar with, you're going to become familiar with in the coming months and years, because this is going to be the dominant technology for using electricity to heat things. And so what is a heat pump? A heat pump is actually something that you already know and interact with. You just may not realize it. A heat pump is something that uses refrigerant to move heat from one place to another. So for example, the refrigerator in your kitchen is using a compressor and refrigerant to move heat from inside the refrigerator into your kitchen. A water fountain that's chilling the water is using refrigerant to pull heat out of the water and dump it into the surrounding space. That's why there's the grills on the side or the vent on the side of the water fountain. An air conditioner, it's not magically removing energy from the planet. What it's doing is moving heat from inside to outside. It's pumping the heat. And a heat pump water heater, for example, is doing the same thing. It's using refrigerant to move heat from outside into the water tank. And so this just gives you an idea of how a heat pump works, or sort of what it is conceptually, and that you actually already interact with these pretty frequently. You may just not realize it. So what's so great about heat pumps is that they're hyper efficient, anywhere from 3 to 5 times more efficient than gas products. They enable zero emissions buildings via renewable electricity, which, as Ken said, San Jose's electricity will be basically carbon free in a few years. They improve air quality, right? We don't have local emissions from burning things. They also improve safety. We don't have gas lines associated with them. You can deliver heating and cooling with a single system, and we'll see that in a few minutes. And also they work in different climates. So some folks may have heard about heat pumps for a long time and gotten an impression that yeah, heat pumps are great, but they don't work when it's cold. Well, the good news is that modern heat pumps, these aren't your parents' heat pumps. Modern equipment can operate all the way down to -13 Fahrenheit. So these things work in a variety of climates and no problem in San Jose for sure. So let's actually start. We're actually going to start with space heating and cooling. So for individual space heating, let's say for a home or for an individual apartment or dwelling unit, you could use a variety of different types of systems. You could use a ducted heat pump, like we see on the left-hand side, a mini split heat pump, and we also have packaged and other types of heat pumps. We have a variety of different options. On the right-hand side, the packaged units tend to be sort of the lower cost options, good for very small compact units like studios, maybe 1 bedrooms. The unit actually shown on the far right that's sort of broken open, that's actually a combination heat pump and ventilation system. So that's doing heat recovery, ventilation, and heating and cooling in a single box, which is a really exciting sort of product category they've had in other countries for a long time, like lots of cool stuff that we haven't gotten here in America, but they're starting to become available more widely in the US. And so that's a really interesting opportunity to get a lot of efficiency out of your mechanical install and sort of get two systems in one and then be done with it. Mini splits, you can do ducted or ductless, and we'll look at some other options in a minute. And then the ducted heat pump on the left, that's a little bit more of like a traditional form factor, like a large AC outdoor unit. You'll see these in sort of smaller buildings that have plenty of space outside. The fan coil or the air handling unit looks very similar to a furnace, right? It's just got refrigerant running between the two units. And remember, so this is for heating with a heat pump, but with a heat pump, you also get cooling, right? So you actually get both in a single system. You don't need to spec a furnace and an air conditioner. You just do a heat pump and you get both and you're done. So that was individual systems. We also have central systems. So central space heating systems, we can do it on the left-hand side. We've got what's called variable refrigerant flow, which is like a really big outdoor unit for mini splits. It can connect to lots and lots of indoor units. These can be great for multifamily. They can serve a whole large number of units. In fact, I have a couple projects in San Jose, new construction that just opened, Park Ave and Laurel Grove Housing. Those are affordable projects built by the Santa Clara County Housing Authority, and they use VRF systems in those projects. You can do packaged rooftop heat pump units, and you can also have heat recovery chillers on the roof. So a heat recovery chiller is sort of, I would say, the most sophisticated version of doing heating and cooling in a central application with a heat pump. These are systems that can supply hot water and chilled water for heating and cooling, and also domestic hot water. However, these are pretty highly engineered systems. They can be used very effectively, but you don't want to have an engineer who it's their first rodeo, perhaps using one of those. They require a lot of coordination and a lot of engineering know-how to work properly. So there are simpler systems that are more out-of-the-box kind of turnkey solutions, but the heat recovery chiller is an option that can work for projects and sort of get everything in one system. So that's sort of like a basic overview. Heating and cooling with electricity, generally we're going to be doing it with heat pumps. And those are just like a preview of some of the different types of options. And in the Q&A, if there are questions about any of those, be happy to talk through in more detail. So let's move on to water heating. Water heating is in many ways the sort of biggest shift for designers and builders in California to do with electricity, or at least to do efficiently with electricity, because we are, as a design community, so used to doing water heating with gas. But turns out you can do water heating very affordably and efficiently with electricity. And you do it with, guess what? More heat pumps. So the most basic type of heat pump water heater is an individual heat pump water heater. This is the kind of unit that could serve a single family home, a single apartment, maybe 2 or 3 smaller apartments connected together. They look very similar to your standard residential water heater that we're all used to seeing forever and ever. There are sort of 2 types of these heat pump water heaters. The one on the left is a split type heat pump water heater where you have the tank and you have the heat pump. And one thing I really want to emphasize with this type of heat pump water heater, and really any heat pump water heater you see that has a box and a tank, all of the refrigerant is inside that box, period. It is factory sealed, done. The only thing connecting the box to the tank is water pipes. So you could just think of it like a little electric boiler that does it very efficiently with refrigerant. There's no running of refrigerant lines, nothing like that. All the refrigerant is contained within the unit. So that's a split type. We also have combined heat pump water heaters where you have the tank and the heat pump all in one unit. Generally, the heat pump is kind of conceptually on top. In reality, they're sort of connected all throughout the unit, but you'll see all of them have openings on the top of the unit to get airflow, because you have to have a way to exchange heat between the air and the water, and that's how they do it on top. So I've got a few example photos of some systems. This is an example of an individual unit. This is frankly in a closet that's probably too big for this. I think they were probably planning on doing a gas water heater, and then they switched to a heat pump, and got more space allocated than they really need. This one shows it being ducted. You can duct them. You don't need to. In fact, for this unit, I think probably a cheaper solution would have been just to fully louver that door you see, and then not even bother to duct the heat pump. Just specify a different door with more louvers, then you don't have to duct the heat pump, and it's totally fine. So that's an example of sort of an outdoor like closet location install. You can also install these just straight up inside of an apartment. So I've got a couple of examples here of apartment heat pump water heaters and sort of where they're located. And on the left-hand side, we have a 1-bedroom, and on the right-hand side, we have a 1, 2, 3, 4-bedroom. And these are not apartments in San Jose. This is a development in San Francisco, but sort of in the Bay Area, you know, similar development costs, tight sites, relatively space-efficient units, and they've managed to find a place for a heat pump water heater inside the unit. So in the left-hand side, in the 1-bedroom, where they've chosen to locate the unit is right here. So if you notice, that blue circle is just above the bathroom, the lavatory. So it's very close to the sink in the lavatory. It's very close to the shower, so very short pipe runs to those major sort of hot water end uses. And it's also pretty close to the kitchen. Another thing I really like about putting the heat pump in this location is that it's close to the kitchen. And remember, what the heat pump water heater is doing is it's actually moving heat. So in order for the water to get hot, something else has to get cooler. Just like your refrigerator in your kitchen, in order to cool down the inside, it actually has to move the heat from inside the refrigerator into your kitchen, right? That's why you feel, I'm pointing over there because my refrigerator's over there. You all can't see that. So your kitchen actually gets a little bit of heat off of your refrigerator because it's actually dumping heat into your kitchen. That's why if you put your hand behind the refrigerator or sort of underneath it, you can feel the heat. It's not a lot, but it's some. And what a heat pump water heater does is actually the reverse. So it generates a small amount of cool air coming off of the unit when it's heating up the water, because it's moving heat from the surrounding air into the water. And so it's not a ton of cold air, but it's some, right? If you put your hand up next to it, you'll feel it. And so what I like about the sort of kitchen adjacent location is that kitchens are, one, a source of a lot of heat. You have a refrigerator that's generating heat all the time. You also cook in your kitchen, which generates heat. And you have lights and movement and stuff. And so I think adding a little bit of cool air to a kitchen in many ways is like a sort of symbiotic relationship between heat and sort of cool. And to me, that makes a lot of sense design-wise. So I really like putting the heat pump water heater adjacent to the kitchen. Again, you can just louver that door and you're good to go. On the right-hand side, they've gone with a little bit of a different approach. What they've chosen to do is, instead of putting it in the kitchen, they decided the best place to put it was actually down the hall. So if you notice, the kitchen in the right-hand side unit is on the left, and we've got a number of bedrooms, 2 bathrooms, and actually a laundry at the very end of that hallway. And they've located the heat pump water heater almost all the way at the end of the hall. So it's near the bathrooms, which is good for the hot water runs. It's near the laundry, which is also good for having short pipe runs. So that's efficient. And they determined that, one, the unit's not, it's very quiet, so they don't have to worry about noise. I mean, it's right next to a bedroom. And they've looked at the sound ratings, totally fine. And they also determined that it's not going to put out enough cool air for it to really make a difference. They're louvering the door to the hallway, and it's fine. So this is an option. This design team decided that this would work for this project. I like the kitchen location a little bit better, but really it's sort of up to you. But there are sort of different ways that you can do it, and it's flexible. Yeah, any questions about individual heat pump water heaters before we move on to central? All right, I don't see any questions, so I'll just keep on rolling. So that was individual. Let's talk about central heat pump water heating. So central heat pump water heating is sort of, there's kind of, really it's two kinds. There's split type, where you have a heat pump and a tank, and then there is a combined type. And there's only one manufacturer making a sort of all-in-one heat pump water, sort of central heat pump water heater. But most of the central or sort of larger commercial size heat pump water heaters on the market right now, you have the heat pump and you have a separate tank. And so we'll see some examples. And I will just say that a year ago, there were not nearly this many different pieces of equipment that you had to choose from for central heat pump water heating. The market is really seeing the direction that things are going, and manufacturers are responding. And they are bringing not new products. Again, this is not new technology. Heat pumps have been around for decades. Heat pump water heaters have been around for a long time in other countries and in other regions. We just haven't had the demand for them here in California, and so they haven't been available to us. But manufacturers are seeing this sort of rapid increase in all-electric construction in California and are rushing to sort of get in the game and bring products that they've had other places. And so they're tested, they've been installed, and they're bringing them to the California marketplace. And so we're seeing a real growth in the options that projects have the options that are available to projects. So I think that's really great. So some examples of a central heat pump water heating systems. We've got this one. You've got a big old heat pump outside that's maybe about 3.5 feet tall. So it just looks like a big heat pump outdoor unit. And you have water pipes running between that outdoor unit and the tanks that are indoors. So the sort of general formula is a heat pump outside and like some tanks inside. That's pretty much how you do it. So let's see another example. Here we have larger heat pumps. This is a bigger building. This is actually on the roof of a large all-electric dorm at UCSF in Mission Bay in San Francisco. And it's a brand new all-electric dorm. They have like over, I think something like 190 beds, and it's for student housing. So they get sort of very high hot water demand for this building. So heat pumps on the roof. In this case, they decided to put the storage tanks on the ground floor, so you can separate them. They don't have to be right next to each other. Generally good to have them pretty close, but you can separate them if you need to. So yeah, that's an example on a new building in San Francisco that's all electric. This is another example sort of similar to the first one we saw. In this case, we have 2 heat pumps connected to 2 large tanks inside. So you sort of start to see a pattern. We got 2, 3, 1, some number of heat pumps outside generally, and then inside usually maybe 1 or 2 or 3 tanks, depending on sort of how it's configured. And then moving to another system. So this is a little bit more complicated looking of a system, but it's actually pretty simple in the way that it operates. So this is a system that uses sort of smaller, what were originally designed for residential use, these smaller heat pumps like you see on the right-hand side that use CO2 as their refrigerant. And what this system is doing is it's actually taking 4 of those small heat pumps and connecting them to one of these large tanks. So each of these large tanks you see on the left-hand side is connected to 4 small heat pumps. This gives a lot of redundancy. It allows a lot of flexibility in terms of meeting the load. And this is a project actually in Sunnyvale called Edwina Benner Plaza, and is one of the first systems of its kind in California. It's been operating for almost 2 years now, and yeah, they're hitting. I think with their PV system, the common area or the owner electric bill is basically 0 on an annual basis, even with an all electric building and heat pump central heat pump water heating. This is another example of a system. This is actually a retrofit system, but they've used the same that same small form factor heat pump as a way to sort of build up a system in a more flexible way. So you can use these in retrofit, you can use these in new construction. Actually, the organization I work for, AEA, we mostly do retrofit projects. And so we're doing a lot of retrofit heat pump water heating systems in the Bay Area and across California. So if you can do it in an existing building retrofit, you can definitely do it in new construction. And that's what we're seeing. In new construction, it's pretty straightforward. So some key design considerations for heat pump water heating. If you take, I would say, one thing away from this presentation about heat pump water heating, I would want it to be that optimal sizing for a heat pump water heater is likely to have more storage. than a gas-based system. So with gas water heating, we've been moving to less and less and less and less storage, sort of the ultimate endpoint of which is no storage, right? Tankless water heating. Tankless gas water heating is very efficient because power, like gas power, is cheap. So you just put a big blowtorch on your incoming water and you heat it with a ton of gas all of a sudden, and that works fine. With heat pumps, we actually want to do it the other way. So the engineer should not size the system using the same sizing parameters as they do for a gas water heating system. You'll end up with a very expensive, both to purchase and to operate heat pump water heating system. An efficient heat pump water heating system is going to have a lot of storage and a relatively small heat pump. So individual systems, those individual heat pumps that we saw, those can be located inside of a unit with no outdoor air. You can duct them if you want to, or if you need to for your application, but you don't have to. But you should always confirm with the manufacturer in terms of like where you're trying to locate them. If you're putting them in a closet, do you have enough sort of venting on the door and things like that? For larger central systems, they will need access to outside air or garage air. So the sort of prototypical location that we're seeing for central heat pump water heaters are a few. One, on the roof. If the mechanical system was planned to be on the roof, roof's a great location, plenty of outdoor air. Also, a lot of projects are putting them in a garage. So especially if it's an open, naturally vented garage, then that's great. You get plenty of air exchange. They're going to generate cold air, but it's all just going to sort of circulate around and be a wash, and that's totally fine. You can also locate large central systems indoors and duct them out. So again, check with the manufacturer, but almost all of the equipment that I showed on that central slide can be ducted. All of the sort of split units, most of those can be ducted. So yeah, you have options for where you put them, and it's just, we just have to sort of like get our heads around what the considerations are that are different from heating water with gas, and we'll be fine. What I tend to see is the first project, it's like, oh, we got to do things a little different. And then the second project for a design team, they sort of learn the lessons from the first one, and then, okay, we need to have our water heater over here, so I need to allocate space there, and then that's fine. And then the third project, they're off to the races, and they don't need to talk to me anymore. So yeah, the last thing I'll mention real quick is actually Title 24 compliance. So as Ken mentioned, historically Title 24 compliance has been a real challenge for all electric, which is really unfortunate. But the good news is that it's gotten a lot better, even this year. As of Q4 2020, there are multiple compliance pathways for all electric multifamily buildings and commercial buildings, with more being integrated into the software sort of with every update. And also, I just really want to emphasize that the folks at the city, like Ken and Ron and everyone there, they're aware of the limitations that are still there in the software, and they're very happy to work with developers and design teams to help overcome any of these obstacles. And that's that's also what AEA's role is, and working with the city is to engage with development teams and see like, hey, what are the challenges that you're facing? What are the questions that your consultants have, and help you all work through those. So yeah, that's it for my section. Ken, are there any questions that have come up?
Yeah, we had one from Jared, just that's in the chat, multi-parter. I think we can cover some of that here, but my recommendation would be to do just what Nick was talking about and get a meeting scheduled. We're also pretty quick to get those meetings scheduled on the calendar. So you would be sitting with us, representative from building, most likely Ron, that would be able to speak to what they could or could not agree to, and then Nick from AEA to help with some of those design considerations. But if we want to get directly into it, I think those are your questions, Jared, are more about navigation around these issues.
Sure, maybe we can, Ken, maybe just like sort of wrap up the presentation. We can come back to it at the end.
I think we've only got a couple more slides.
Cool.
Yeah, so in addition to what we're doing here in San Jose, the state has committed to statewide carbon neutrality by 2045. You're seeing a lot of that make the headlines in the last couple weeks. Again, we're going to be hopefully carbon neutral on our electricity blend sometime next year, or pretty close to that. One thing to note about still installing gas systems is that there really is an electrification wave. It's going to be pushed at the local and state level, and as everybody moves to electricity, that gas system cost is going to be kind of paid for with a shrinking island of gas customers that have to absorb that. And we've all seen kind of the liability issues and so forth that have come with that. So that's going to have a market effect on gas rates. Makes sense to get people off of that system now. Again, helps with our climate smart and American Cities Climate Challenge goals. And then we've got the state identifying cost effectiveness pathways to get this done. Next slide. And that's it. So we're, again, we're going to be at council on November 17th. I expect that the agenda for that meeting will post by November 9th at the latest. If you want to check that that agenda site, there's and these days of COVID meetings or Zoom meetings, there's an e-comment link there that you can submit comments to. You can also tune in for the meeting itself and do public comment that way if you'd like to participate in the process. I think that's about it for the presentation now.
Cool. So Ken, I see a question actually a little bit further up in the chat from Christine. Christine says, I have a question about refrigerants used in the heat pumps and whether there are some restrictions on using ones that use compounds that add to the depletion of the ozone. If not, there are any considerations in implementing that. So Christine, you're absolutely right. Ozone depletion and also global warming potential is a concern around refrigerants. And the US EPA has already phased out some of sort of the worst ozone depleting refrigerants in the sort of previous few decades. And there is movement to sort of work on lower global warming potential refrigerants. So a couple of the heat pump water heaters I showed actually use CO2 as the refrigerant. And CO2 is a super environmentally friendly, very low global warming potential refrigerant that also performs really great. So there's refrigerants, I think generally are regulated at the federal level, maybe somewhat at the state level. There's not anything in the REACH code specifically about regulating refrigerants. And even when you account for the global warming potential of refrigerant, and if you assume that all the refrigerant in a new heat pump system will just be vented to the atmosphere, which it's not supposed to be, which there are like laws requiring the recovery of refrigerant when a system is disposed of. Even if you account for that, you're still saving tons of greenhouse gas emissions by switching from gas to a heat pump system. So we do need to manage our refrigerants and sort of reduce the impacts of them. But even sort of worst case refrigerant management, heat pumps still are a major climate win over burning fossil fuels.
And then we had Jared's question on process. Jared, jump in if we can clarify further.
Yeah, also folks, you're welcome to unmute yourself. We can kind of have a free-for-all here if people want to chime in and just ask questions like we're in a real room. There's a question from Seema. Retrofits, are the water heating and cooking units comparable with regard to efficiency and cost effectiveness? I guess I'm not sure comparable with what. Seema, if you're still on the call and want to unmute yourself, just to clarify sort of the question.
Sure. I mean, a lot of homes in the Bay Area especially are older homes, and the new REACH code is for the newer homes. So
Correct.
If we were to encourage people to retrofit their existing homes with electric units, is there data that we could share saying that natural gas, for example, right now is cheaper than electricity in certain cases? So how might we do the comparison to make it effective for people to consider switching?
Sure. So I think for addressing existing buildings, like you said, the REACH code currently does not, it only applies to new buildings. So I just want to make sure that's super clear that what we're talking about today only applies to new buildings. However, existing buildings are, a big challenge and sort of will be a big challenge going forward. The good news is that there are a number of state and regional programs to actually give incentives for folks to do energy efficiency in existing buildings and also to electrify end uses. There is a program in San Jose called Electrify San Jose that is offering very juicy incentives for electrification of I think single family and like low rise multifamily.
Yeah, it's specifically for heat pump water heaters. It can be layered with the regional rebate that's available through BayREN, Bay Renewable Energy Network. But I think maybe the short answer to your question is, once you have those devices in place, they're going to be more efficient and cost effective. But yes, there will be an initial cost to purchase, obviously, the unit and upgrade, in a lot of cases, the electric panel. That's where the rebates need to come in. We have some in place now. The state's going to be entering that arena, I believe, by next summer, in terms of additional incentives to make those conversions hopefully painless for the homeowner.
Thank you. That's helpful.
Next up, Nathaniel, I think.
Yeah, let's see. For a mixed use building that could have retail space for future use, is the main developer allowed to put in for the waiver to have gas installed, or is that something that would need to wait until the retail space was leased out, with the gas connection waiver only being allowed at time of TI plan submittal to the city? This is above my pay grade. I will defer to Ken or Ron.
And I will defer to Ron on that one.
So yeah, we want to see, we would want to see in that case, the TI at least identified early on in the process. That's not to say you couldn't run gas to the building if the TI had been identified as a restaurant. But typically we're going to want to see a strong commitment to putting a restaurant in that gas is going to go to for the cooking equipment only. So yeah, it can be done, but you're probably on the right track. That the TI would be the key to getting gas to that building, because that space could also be used for other retail that would not need gas. And I saw their question come up, what is a TI? A TI is a tenant improvement.
And then I think we just had some follow-up from Pete Kennedy and again, Jared, regarding a meeting. And like I said, we are literally standing by and ready to meet whenever you have enough detail for us to answer questions on that. And then Mike, will commercial kitchens with gas be allowed in senior housing projects? I think
This is an interesting edge case.
Yeah.
We've talked about it before. I just curious.
So I think that fell under our commercial food service production. Did it not, Ron?
Yes, it did. As a matter of fact, the extended gas ban speaks directly to that. So yes, they would be allowed under the extended gas ban, which I guess what you're asking, Mike, is would they be allowed today? And I would say yes, they would be.
Will they be allowed November 18th?
Yes, they
Okay.
would be.
Yeah.
Okay.
And then like I think I mentioned early on, the effective date of this new proposal would be August of next year. So even after that, you would be able to apply for an exemption for that purpose, at least up until the end of calendar year 2022.
Okay, thanks.
Mm-hmm.
Ken and Ron, I have a question. In terms of the sort of the exemption, is it just you apply for an exemption or you get it, or you apply for an exemption and you have to actually make a case that there is like a legitimate need for the exemption versus just preference?
Yeah, no, you would have to apply for the exemption, and we would need to see a legitimate reason for that exemption to go in place. So all gas to the buildings will be required to go through an exemption process. It's not lengthy and it's not a bunch of red tape. It's just to make sure we document that there is an actual need for the gas to go into that space, and that also the understanding of electrification for future conversion to electric appliances would be part of the deal also. So yeah, it needs to be through a process that you can apply for. You can contact myself, or you can contact Ken to get the method of how to do that.
And part of that is really just gathering data over the next couple years too. That January 1st, 2023 date is not that far off. If we're having to grant a lot of these, maybe there's a case for another extension, maybe not. But part of that will be gathering that data.
So Ken, it looks like there's another question from Marie. Does the gas ban increase construction costs for low-income multi-dwelling housing? So Ken, so most of the projects I work on are actually affordable housing. And what we're finding is that a lot of affordable developers are choosing to build all electric before there's any legislation in place to sort of compel them to do it. And they're choosing to do it because it's actually more cost effective for them to build that way. And then also Ken mentioned the cost effectiveness studies that show that you can get a lower life cycle cost, sort of lower total cost for a project by building all electric. And that's, you know, like all cost data, it's on average. So like costs are gonna vary a lot from project to project. And also costs are gonna vary depending on sort of who did the cost estimate. And like if, you know, I've seen cost data that makes me wonder, you know, what assumptions they were using to come up with it. But there was like robust and sort of vetted cost effectiveness studies that were done to sort of back up this ordinance. And I can just speak from also my personal experience that a lot of affordable developers, particularly ones that are based in San Jose, like First Community Housing, they're building all electric because they want to and because they feel like it's the right thing to do for their portfolio.
Yeah, I would agree with that, Nick. There's also not just low cost housing, but some of the high-rise office buildings and so on are choosing to go all electric voluntarily. And that really is the trend, because I think that the developers understand that that's what people are looking for. And that's also the commitment to the city's, climate smart plan to make sure that we're not over polluting when we don't need to. So the technology's there and the willingness is there. I think we have a winning group here that's stepping up and doing things voluntarily, which is really great to see.
Yeah. Karen has a question about the water heater program. That's been in place since 2018. Obviously things activity-wise this year have been a little slower. There's been some stuff going on. We just extended that grant, which came from the Bay Area Air Quality Management District through, I believe, the end of April next year. Not sure if we make it that long. We're probably at about 2/3 of the way through that funding that was provided. However, there is more state money coming into play towards getting closer to next summer that could replenish that or take a different form. Any other questions people want to jump in with? Oh, retrofits. Yeah, so the just for purposes of perspective, what we're doing here is with new construction is really an incremental piece of the pie. It's a small piece of it. Most of the gas is out in the built environment already, and to get to that point, it's going to require concerted effort, and that will include a lot of funding at the state and local levels. Hopefully the federal level as well will be able to kick into that at some point. But like I said, I think it's, Ron, wasn't it 1978 was the panel change era? I think houses built after that had a larger panel and can probably do some of these things easier.
Possibly.
Yeah.
Yeah.
So before that, like where I live, there's, I got an EV a few years ago. In order to have a charger put in, that required a panel upgrade. But the panel upgrade would also allow me to do other fuel switching in the house in terms of the water heating or the stove. So are there specific plans right now? Not right now. We're going to kind of wrap this up with new construction and move into that area and keep encouraging folks to switch.
But I would say there are like very clear sort of guideposts that are there from the state in terms of where we have to get as a state in terms of carbon neutrality. Like it's already law that electricity in California will be carbon free by 2045, and our entire state is supposed to be carbon free by 2050. So, you can kind of connect the dots. Like we're going to have to do a lot in existing buildings over the next 30 years. And so we need to not wait too long, but those sort of, we're trying, new construction is the easiest, right? The buildings don't exist yet. And so we're working on that and getting that sort of essentially stop the bleeding. Let's stop building new fossil fuel infrastructure. And then once, okay, we're not building any more new infrastructure. Now we can work on our existing fossil fuel infrastructure.
And then from Miramar, actually, we just had this conversation earlier today. Once the grid is carbon neutral, would we get back to electric resistance heating? I don't see that happening. I don't even know that it would pass a compliance test right now.
I'll play a little devil's advocate.
Okay.
Technically you can. Like, it's not that you're not allowed to do it, it's that code makes it difficult. So if you make the rest of your building real efficient, you can do it. The heating bill is gonna be a lot higher relative to a heat pump. But I mean, electric resistance is very, it doesn't break ever. It's got almost no moving parts. But the other thing is that in San Jose, you need heating and cooling. And so if you need a cooling system, you may as well just have a heat pump, because then your cooling system is the same as your heating system, and you just have one system and you're done. And then even in this conversation is happening a lot sort of in more like North Bay, East Bay, where they're used to building without cooling. But even then, we're really, like, when I talk to projects, like, I'm trying to encourage people to think about building not for how we think of the climate having been in the Bay Area for the last 20 years, but how has it been this year? And then think about this year, but like much worse in terms of heat waves. Like, that's what we're building for. We're building buildings for the future, not for the past. And the future is going to be hotter. And so if we need air conditioning in our buildings to stay comfortable and really to stay like healthy and safe during heat waves, if you have air conditioning, you may as well just get a heat pump that does air conditioning and also does heating, and then you just have one system and you're done.
Good questions.
But yeah, I see your note about climate zone 3. That's exactly where people are very used to building without cooling. And I actually am really encouraging folks to think very carefully about whether that's still the right thing to do.
Question from Christine on microgrids as a way to mitigate the effects of power outages. Are there projects underway to implement those? We're looking at a couple of those for some city facilities, which would be a combination of photovoltaic and some battery storage. I think it depends on the setting and sort of the maturity rate of the battery systems and being able to cover that power demand for an adequate amount of time. Any other thoughts there, Ron or Nick?
I feel like microgrids are these things that people have been talking about for a long time, but very few people have actually done them. So I don't know. It's like big data. Right. It's like, what is it? Everybody says they do it, but it's anybody who does it. I don't know.
Yeah, I don't know.
I feel like that's the kind of thing that like large institutions that have like campuses and many buildings and lots of capital and like they have 100-year sort of ownership period for their built campuses and large institutions. I've heard of doing things like microgrids, but sort of at the city scale, it can be difficult to do unless you have like a big city campus of like multiple buildings all connected together. Like San Francisco might have that with like Civic Center where they have a lot of different buildings connected together that can sort of share energy resources between each other. But sort of that you need a lot of things to be very tightly connected to do that.
Other ways to help reduce the impacts of power outages.
PV batteries and islanding.
Yeah. Fortunately for us here, we haven't been overwhelmed by that. It's been towards the hilly fringes of the city. It's really about kind of what is going to be the fate of PG&E, and I don't have the answer to that, but certainly there's been discussions regionally at the state level that should be something that's publicly owned and maybe maintained in a different way. We're still a ways out, I think, from an answer to that question. I would say that you do have a longer recovery period coming back online with a gas system typically than you do with electric. So. I know a lot of like residential settings, the newer PV systems are being marketed with the battery pack that is, I think, bi-directional with the grid. So if you do lose power to the grid, the battery system could kick in.
Some are that way, yes. Not all.
Mine's too old. The inverter doesn't do that, so.
Right. Yeah, and I would suggest anybody putting solar on with batteries would make sure that their system could be used in a power outage, because some of them can't be.
And then the other note on that is just that a lot of the gas devices have some electrically powered component to them, so they're not necessarily available during an electric shutdown. Other questions from the group? We are just about at time.
These are great questions. These are some of the best questions we've had on one of these webinars. Thanks for asking good questions, everybody.
Yeah. If not, we'll let you all go get some dinner. And we once again thank you for your time today and appreciate you being here.
Thanks, everybody.
Thank you.
Thank you.